So, what are some of the concepts and skills that we need for 2D motion and vector problems? First, we need to know some geometry. We use triangles a lot, especially right triangles, so we need to know how to find the side lengths and angles using the Pythagorean theorem and the right triangle trig functions, sine, cosine, and tangent. We should also be familiar with finding different angles in sets of triangles or parallel lines. And it's not as common, but circular motion is two-dimensional motion, so we might need to know some geometry about circles. Next, we need to be familiar with coordinate systems. We usually use a Cartesian coordinate system, and we label the axes as x and y, each with a positive and negative direction. For some problems, we need to work with axes that are rotated or even flipped. We also need to know how to use coordinates to describe the position of a point or an object within a coordinate system. Next, we definitely need to know how to work with vectors. We should be able to at least roughly draw a vector when given its magnitude and angle. We should also be familiar with the different ways that a vector's angle can be described relative to other axes or directions. We need to know how to find the components of a vector and how to find its magnitude and angle. And we also need to know how to add vectors, either graphically by using the tip-to-tail method, or mathematically by adding their components. Finally, we need to be familiar with the one-dimensional kinematic equations. We might be working with an object in two-dimensional motion, but we're going to be answering questions about its motion either in the direction it's moving if it's a straight line, or we're going to find the x and y components and use the 1D kinematic equations for each direction. Those are some of the key concepts and skills that we need, and you can go back and review anything you're not familiar with. Now let's cover some tips for solving these types of problems. Tip number 1, always draw a picture. You should always draw a picture at the start of a physics problem, but it's especially helpful and sometimes necessary for 2D motion and vectors. Draw things big enough to fit everything that you want to include. Use a picture as a helpful reference, but remember that it may not be accurate. Unless you use a ruler and a protractor, your vectors and angles probably won't be accurate. For example, if we're given the magnitudes and angles of vectors A and B and asked to find their resultant vector C, the vectors we draw might not be accurate enough to show us if C points in the positive or negative x direction. So it's always good to draw things out, but trust the math instead of your picture. Draw the x and y axes if it's useful for the problem, but it's not always necessary. Keeping track of your directions and signs is important, but if the problem is simple enough, you don't always have to apply the x and y axes to the situation. And remember that when we draw vectors, they can be moved around. So even if a vector is attached to an object, you can draw the vector at the origin to see its angle relative to the x and y axes. Tip number 2, know the different ways to describe angles. Pay attention to the wording around angles and make sure you understand exactly which angle is being given or which angle you're being asked to find. Use the conventional angle, where positive angles are counterclockwise from the positive x-axis, in these cases. If you're just working with a vector and it's not related to a physical scenario, especially if there's no units, if the angle is relative to the positive x-axis, or if the angle you're given is greater than 90 degrees. But in most other cases, when in doubt, just use a positive reference angle. That usually just means a positive angle inside a vector's right triangle relative to the x-axis or the horizontal. Also, make sure your calculator is set to degrees instead of radians if that's what you're working with. And tip number 3, turn a 2D problem into a 1D problem. If you're given, or you're starting with, a 2D vector, and you're asked about the motion in the x or y direction, or the horizontal or vertical direction, Then you can find the components of the vector and use the 1D kinematic equations for each direction. Or you can start with two 1D motion components and use them to find a 2D vector. Remember, there's no 2D kinematic equations, there's only a combination of 1D kinematic equations.